right. Section 2.3 talks about measures of central tendency. This is going to be the one that most people are probably more familiar with than anything because we're talking about mean, median, and mode. First one is your average, better known as the mean. In order to find the average, we do break things up now into a population and into a sample. And so you're going to see definitions come up now for population and for the mean. We also see some Greek letters now that are involved. This funny looking U is called mu. The E, you probably already know, is sigma. And that is an uppercase sigma. Sigma, by definition, when we're talking about it in the world of statistics, means to sum or to add. This symbol right here, that looks like an X with a bar on top of it, is read exactly that way, X bar. So we read this as X bar. We also tend to interchange. So sometimes you'll hear X bar, sometimes you'll hear mu. So it's just one of those things that it can easily, sometimes just because people don't know whether you're talking about the population or the sample. So depending on which one you're talking about is what people will say. But if you look at the formulas, you notice it's exactly the same formula. To find the mean, you're going to add up all of your data entries and divide by the total number. Whether it's N for the number in the population would be capital N versus the number in the sample would be considered lowercase n. But it's still the same formula. So if I find the sum of this one, I'm going to add all of these up. So 274 plus 235 plus 223 plus 268 plus 290, 285, 235, add all of those up. Divide by the number that there are, 1, 2, 3, 4, 5, 6, 7, divided by 7. And if I do this on my calculator, I end up with 1,810 divided by 7, which is approximately 258.6. Because we know this is a sample, this is equal to X bar, or the mean. The next one is our median. The median is the value that lies in the middle of the data set when the data set is ordered. So we do have to make sure that we are in order. If you have an odd number of entries, the median is that middle number. If you have an even number of entries, then you have to find the average of the two middle ones. So using the same data set, find the median of the weights listed in the first example. So I am going to put them in order. So 223, 235, 235, shows up twice. So 233, 223, 235, 235. The next one would be 268, and then 274, and then 285, and then 290. So again, we know we have 7 pieces of data. So the middle piece would be the 4th piece of data. Or if you're not sure how to figure out which one you're talking about here, you can take your first and last and cancel those out. Second and next to last. Third, and then just cancel until you're left. You're left with the 268. So in this case, the median is indeed equal to 268 pounds. In this case, as it is talking about weight. So it says next, in the previous example, the adult weighing 285 decides not to participate in the study. So what is the median weight of the remaining adults? Well, we still have the 223. We still have 235 twice. We still have 268. We still have the 274. The 285 opted out, so we're not going to list him. And we have 290. So if we do the same thing that we did before, this value and this value would cancel out. The next two would cancel out. And lo and behold, you're left with 2 in the middle. If you're left with the 2 in the middle, we do have to average these two. So 235 plus 268 divided by 2. On your calculator, just so that you are real careful, notice on your calculator, if I do 235 plus 268 and I divide it by 2, that is not the correct answer. I can do this on my calculator one of two ways. 235 plus 268 equals, or enter, divided by 2. And my average would be 251.5. The reason I knew 369 couldn't be my average, because that's larger than my 268. And it all has to do with order of operations, because in fact we want to add before we divide. So if I put parentheses around the 235 plus the 268, that now gives me order of operations and tells me to add those numbers first, then divide by, not 7, but 2. And now I'll get the 251.5. I tell students all the time the calculator is only as smart as the person using it. So if you're using it incorrectly, you're going to get an incorrect answer every time. Do not wait to practice on your calculator. Make sure that you spend ample time practicing before you get to a test. So my average here ended up being 251.5. And again, that was my median this time. So the median, or the middle weight, was 251.5. Last one that everybody associates with pretty easily is mode. Mode is the entry that occurs most often or most frequent. So again, in our data set, if you look back at the original data set, you notice that the 235 appeared twice. So my mode in this case is equal to the 235 that appears twice. You can have more than one mode. So if two numbers appeared more than once, then you can have something that's called bimodal. If you have no entry at all that occurs more than once, there is no mode. So mode can have a number, it can have multiple numbers, or it can have no answer. All right, next then. The table shows the sample ages of students in a class. Find the mean, median, mode of the ages. Are there any outliers? And what measure of central tendency best describes the typical and atypical entry in this data set? So first thing I'm going to do is find the average. So if I get my calculator out, I'll do 20, 1, 2, 3, 4, 5, 6 times. So 20 times 6, I can shortcut it. 1, 2, 3, 4, plus 21 times 4, plus 22 times 3. I hit the right button. Times 3, plus 23 times 4, plus 24 times 2, plus 65. Hit enter for sure before we do the division. So there are in here 1, 2, 3, 4, 5, 6, 7, 14, 20 entries. So I'm going to divide by 20. And my average age of the class is 23.75 years. So the average, which in this case is going to be X bar, because it says sample ages. So the X bar is equal to, we added them up, we got 475, we divided by 20, and the average age is equal to 23.75 or 23.8 years old. The median, again, which one is in the middle? Well, we have an even number, and it said, if you recall, whenever we were talking about median, if it's an even number, we are going to have to find the average. So there should be two numbers in the middle. The two numbers that are in the middle would be 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the two numbers in the middle are 21 and 22. So the mean then says to take 21 plus 22, divide by 2, and we get 21.5. And this would be the median. And then last would be the mode. What number occurs most often? Well, we have the number 1, 2, 3, 4, 5, 6, 20 that occurred 6 times, and everything else occurred less than 6 times. So the mode is 20 years. Right? Is there an outlier? That's the next question. An outlier is a piece of data that doesn't really fit with what you would think. Well, if the average age was 23.8, the middle age is 21.5, the age that occurs most often is 20, and I have this number sitting back out here at 65. That really doesn't fit any of the data set. It's really way far out. So since it's outlying, it's outside of the data, it really is not, it's not going to make a whole lot of influence on everything else. Right? So then the question says, which measure of central tendency best describes the typical data? Well, since 65 is an outlier, 65 does not influence, well, it doesn't influence the mode, and it doesn't influence the median at all. Since the median is the middle number, it doesn't really influence the median. It doesn't really influence the mode. The average does include the 65. So it's possible that the average then is influenced by the median, or by the 65. So, which measure of central tendency best describes it? Well, what might be best might actually be then the median. That one might give us the most helpful information. Mode doesn't really help us any. The mean, even though the age 65, it does affect the average. So the mode doesn't matter. Average is affected when we take the mean. So the median is probably the piece of data or the central tendency measure that describes the data correct. Or describes the data most accurately. And again, you'll have to just look at your data sets and see how all that factors into what you're doing. Right. Next thing we talk about is a weighted mean. And a weighted mean is the data set whose entries have varying weights. And so, truthfully, the way I sort of calculated the average on my on the calculator for the previous problem was almost sort of weighting them because I didn't want to have to type in 20 plus 20 plus 20 plus 20. So it sort of did the same thing. However, weighted means can also be found whenever we're looking at things that really don't measure the same. I was doing the mean by counting the number of data points. But in this case, when we're talking about finding the weighted mean for your GPA, you have to look at it because each of the grades are worth more or less depending upon what your credit hours are and what your grade is. So for this one, I am going to extend a couple more chart pieces. This is going to be my point value. And this is going to be the points times my hours. So the point values are X. The credit hours we're going to call W. And so this last column is going to be W times X. So it tells us that a C earns 2 points. A C earns 2 points. A D only earns 1 point. An A earns 4 points. A C again earns 2 points. And a B earns 3 points. And I got that information from right here, which tells us what everything is worth. And so even though he has 3 C's, each one of these C's is weighted differently because this one's worth 3 credit hours, where this one is only worth 2. And in his case, the one that was worth the least also happened to be the one he got the D in, which is good. It's going to affect his GPA less because the point values aren't weighted as high with 1 credit. So now I'll multiply. 3 times 2 is 6. 4 times 2 is 8. 1 times 1 is 1. 3 times 4 is 12. 2 times 2 is 4, and then 9. Add them all up. If I add up all of these, I end up with 40. Add up my credit hours, and I end up with 16. So my weighted, or my GPA in this case, is equal to 40 divided by 16, which if I use my calculator ends up with a GPA of 2.5. And that is exactly how Lone Star will determine your GPA, and all colleges for that matter. That's why they always tell you it's on a 4-point scale, because an A is worth 4, the F is worth 0. All right. Next, it says that we're going to look at the mean of a frequency distribution. All right. So here is your formula. Again, you're taking your X values and you're going to sum up X times my frequency. You're going to divide by N, and N is the number in your sample. So X and F are the midpoints of the frequencies of the class respectively. That's what's given to us. And it says find the mean frequency distribution for the following set of data. The frequency distribution shows the out-of-pocket medical expenses in dollars of 30 U.S. adults in a recent year. This should look familiar from a previous example. Use the frequency distribution to estimate the mean expense. Using the sample mean formula, the mean expense of $280.5, $280.50. Compare this with the estimated mean. So again, we're just going to use the formula. So X bar is equal to the sum of the X times the frequency divided by the number in my sample set. And what's nice is they've already done the addition for you. So we're going to take, and they've even done X times F. If you look at your column right here, that's X times F. So 172.5, and there were 3 people. So that gives you this. 208.5, and there were 2 people, and that gives you this number. Again, very similar to what I did when I found the average age in the class. Very, very similar to what I did. All right. So if I add this all up, it tells me that was 8,631 divided by the 30 data points, and my average is approximately 287.70 cents. And this now is an estimated average. It's an estimated average. They said the real average was $285.50. So, what do we conclude? Well, the regular average, the actual average, or the actual mean is more accurate than the estimated. And that's often the case, again, because this is an estimated piece. And the reason we know it's estimated, remember, is because you're looking at the midpoints of these classes. So they're not the exact number, but a midpoint. So it makes a difference. All right, then the last thing we're going to talk about now is the shape of the of distributions. The first one is somewhat, we're going to talk more and more about this, but it's definitely symmetric. So basically, if I were to draw a line through the center of it, let me change colors. If I were to draw a line through the center, then what looks like the left half mirrors what's on the right half. That makes it a symmetric distribution. It also says that the halves are approximately the same, so they may not be exact, but they are going to be approximately the same. And more importantly, your mean, median, mode are all pretty much the same, right there in the dead center of the curve. A uniform distribution is going to look just like a rectangle. Here's your rectangle. Yes, it is symmetric, because if I were to draw a line down the center of this, it is symmetric, but the difference is it doesn't increase or decrease. It stays uniform. So that means it looks like a rectangle. But the mean and the mode are the same. I'm sorry, mean and median are the same. There would be no mode, or the mode would always be the same number, 20, because it occurs for each one of these data sets. Then we have what we call skewed left versus skewed right. And skewed left means that if I were to do the ski slope, it's going to be skewed where it's steeper to the right, but more flattened as it goes left. So it flattens left. Where this one flattens out as we go to the right. So this one is flatter, or flattened right. So the tail elongates more to the right. So this also tells us that the mean is to the right of the median. So here's your median. The mean is to the right. Versus one that's flattened left tells us the mean is to the left of the median. A lot of what we do in statistics, when we talk a lot about different shape curves, we're going to talk a lot about this symmetric distribution, because for you, that's going to become what we call bell-shaped. And again, we'll talk more about that very soon. All right. One last thing I do want to show you. And that's how to use your calculator to find mean, median, and mode. And so if we take a look at the data that we had, let's see. Let's look at the age data. So let's look at this. Actually, where's the weight? So we found the weights. Okay. So here's your weight data. And so that weight is 223, 235 twice, 268, 274, 285, and 290. So how do you use your calculator? Because your calculator will give you a lot of information. And when we get to the next section, we're really going to be able to rely on our calculator. So just really quickly so that you know. Again, we were looking at the weights. Now we said we had 223, 235 twice, 268, 274, 285, and 290. So on your calculator, notice this button right here that says Stat. That's where you're going to do a lot of your data pulling. Right? We're going to do a lot in Edit, and we're going to do a lot in Calculate. Edit is where you're actually going to enter your data. So Edit is Enter. So we're going to, on the calculator, so using the TI calculator, we're going to hit Stat, and then number 1 for Edit, and that's how you enter the data. Another feature that you're really going to want to know on the side is that if you hit second quit, this takes you to the home screen. And so you're going to need to get to the home screen. And sometimes it's not easy to do. You can't just hit clear. So I'm going to hit again the Stat key, then number 1 for Edit. And now I'm given a whole bunch of lists with which to enter data. I'm going to enter my data. So I have 223, enter. 235 twice. Hitting enter in between times. 268, 274, 285, 290. I have 7 pieces of data. This tells me that I'm on the 8th piece, but I didn't enter anything, so I have 7 pieces of data. Right. Now, again, we got to go to the clear. We got to get back to the Stat key. We got to get back to the home menu. So we can hit second quit, and that'll take me to the home menu. Then, to calculate things on here, I want to hit, again, the Stat key. But then I'm going to tab over to the Calculate button, because now I want to calculate some things on there. What I want to calculate, again, is number 1, which is your one variable statistics. So one variable stats. So depending on your calculator now, when you hit this stat key, tab over to get to the calculate button, number 1 to get to the 1, now you have to answer the questions. And depending upon which version of the calculator you're using, you may not see it listed this way. It might just open a set of parentheses for you. But in any case, remember we entered our data into list 1. So you want to make sure that says list 1. By default, it does say list 1. The frequency list you're going to leave blank. So I'm just going to tab down to calculate. I'm going to hit enter, and it's going to give me a whole bunch of information. It also tells me, because this arrow is here, it tells me there's more data below it. So if I tab down, I get more data. If I tab up, I get the beginning of the data. So this little arrow right here tells me I have more data to see. So the max is the last thing. Okay. So if you look at the weight, you notice that the X bar, your average is the 258.7 or 0.6, which is what we said the average was. So again, after you do this, you're going to be able to tell me the average. So X bar is your average or your mean. In this case, if I look at, this is just the sum of all the X values. So I summed all the X values. This is the sum of all the X values squared. And I'll tell you why we do that when we get to the next section. Then we have this S of X, and this, again, that's another sigma, but that's lowercase sigma. It tells me the number in my data set was 7. It tells me the smallest number was 223. The first quartile, and we'll talk more about quartiles soon. So the minimum number was 273, but right here is also the mean, 268. There's Q3, there's your max at 290, and it gives me the information. So you're going to do this a lot. You're going to do the stat, number 1, enter to enter the data, or edit to enter the data. Stat, calculate number 1 for the 1 variable statistics so that you can get the information that you need. Again, if you haven't played with your calculator, then please make sure that you do that. If you don't have the menu, then you might see where it says 1 var stats, and it's got a parentheses that's open. So then you would do list 1, comma, and then, and you don't even need anything other than list 1, actually, just list 1. And even by default, if everything is in list 1, then you can just hit 1 variable and enter. Play with your calculator until you get to know it well. That wraps up section 2.3.